This is the fifth video out of 10 for the tutorial that describes setting up the simplest simulation with Lumerical software. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. This part discusses setting up a light source to excite the simulation domain. Similar to the previous cases, we are going to write script lines for the source. We are going to create a source after that, and the parameters designated in the script will be automatically populated in the source settings. By the end of the previous video, we have already created all objects that we need for the simulation. To be specific, we have defined two objects in the computational domain: spherical particle representing the non-antenna and rectangle representing the surrounding medium. The next step is to set up an excitation source that performs the role of light illumination. We use a short script similar to how we do in the procedure of setting up the objects. For that, again, we select model and we right click and choose edit object. We go to the tab script. Earlier, we have already introduced two objects and we have lines of scripts for them. Here, similar to the case with object, we need to type a short script with settings of the excitation source. We type the select command, and after that, we're going to name our excitation as source 1. So we are going to associate variables with an excitation source that has the name source 1, and we are going to use it later. For the source coordinates, we apply the same consideration as we applied to the object rectangle. Here I would like to show an example illustrating that we can introduce not only the span of the dimensions, but we can also use a coordinate minimum and maximum to define the range. I type examples of using x mean and x max for the x coordinate. Next, I use y mean and y max for the y coordinate. We need to set up only two-dimensional source close to the domain boundary. For the z coordinate, we need only one number, and that will be the coordinate of the plane wave with light excitation. We use a variable h source that we defined earlier in the list of variables. We type the coordinate z as h source. We click apply, and again, the software warns us that there is something wrong with the script. The issue is highlighted in red color. We know that it happens because we haven't defined the excitation source with the name source1 yet. After we are done with the script lines for the excitation source, we have several options to proceed further. One of them is to add script lines for another element in the simulation domain, for instance, field monitor settings. Technically, we could type all these settings at once. We would need to type commands for excitation source, field monitor, mesh parameters, and general FDTD settings. You can do all the scripts at once if you have more experience with this kind of coding. If you don't have the experience, it's probably better to type settings one by one. At this stage, we have completed a short script for the excitation source named source1, and we click OK. And as always, it's important to save project regularly. And this completes the fifth video on numerical simulation with the Lumerical FDTD tool.